good morning, or good afternoon, or good happy midnight. I don't know what time you're watching this. This is probably the 5th time now that I've started recording this and doing it again. Because I forgot things, the cover slide wasn't right, my phone just went off to wake me up because I shouldn't be awake this early, apparently. But what's gonna happen next? I forgot water once. I have it now. Okay. This is week 3 of distance learning, 2nd week of chapter 9. So we're doing 9.2 degrees and radians today. We got through chapter 7 before other people did, so we're going to do a little extra in chapter 9, but it's going to be great. You're going to just be ahead, so I'm not worried about it. I'm so excited to teach you about degrees and radians because this is one of my favorite units to show people things, like animations, but I can hardly do it in class because I keep switching things, so now I just have it as part of my lesson, which I think is pretty cool. You know, whatever. Okay. I'm technically on page 55. If I reuse this next year for some reason, this is going to be meaningless, but I'm on page 55, and we're doing lesson 9.2, and I need to pull up my notes, so just, there it is. Okay. So, this isn't even going to work for me. I don't know if you can hear it too, but there's like a road near me, so it's always super loud on my end, and I'm always afraid. I'm feeling kind of springy today, so we're going to use pink and green in case you want to follow along with colors too. But this is degrees and radians. And my completed notes are going to be posted on the Google Classroom. I did it last week too, but I totally spaced doing it ahead of time, so hopefully you noticed. Sorry, man. Okay, so before we talk about degrees and radians though, what we want to talk about is this thing called an angle. And here's the thing. I know that you can show me what an angle looks like. You might like do a baby shark thing or whatever, but what is it really? It's the measure of the change. So we're gonna get kind of jargony. From the positive x-axis to the terminal side. Okay, now here's what I want to highlight for you. We're thinking about this like a graph. Okay, we're thinking about this like a graph. So what we measure is from the positive x-axis. Here, let's start color coding. Which is this, okay, to the terminal side. Which, if I have an angle, maybe looks like this. So that's my terminal side. It's the side that it ends, the termination. Terminator. You know what I learned? Is that the line from daylight to nighttime on the Earth is called a terminator line. Who knew? So this right here is the angle itself. This is the measure of the change. An angle's not something that we measure with a ruler, something we measure with a protractor. It's how much it's changed from where it started to where it ends. That's the key to angles and degrees. Angles, degrees, and radians. Okay? So, a long time ago, they, probably Greek, I don't know actually, I should have looked this up ahead of time, decided that they're going to use 360. They're like, that's an easy enough number to divide by a bunch of times. It's completely arbitrary. It has no meaning other than it divides by a bunch of things. It's also fairly close to the number of days we have, so it might be related to that, but it's not exact, so why would they even bother? But they were like, okay, here's what we're going to do. We're going to say that if I start looking in one direction and I turn all the way around, that's 360 degrees. So they say that all the way around is 360 degrees. because they just decided the whole thing was 360. So if I go halfway, that's what? That's half of that. That's 180 degrees. Okay. Okay, cool. So a whole 360 is exactly where you started again, and a 180 is going that way. I hear all the time people in the real life saying that they did a 360 and turned their life around. No, they didn't. If they did a 360, they're going the same way they started. So if you want to turn your life around, you do a 180. Okay. So from this, we get two other numbers too. We get straight up, like this, is 90 degrees. And then all the way down is 270. So we're going to label all of that in a little bit, but I just wanted you to have that idea. And if I don't go anywhere, it's 0. Okay. So let's learn a new word by doing an example. We're going to draw 500 degrees, okay, in standard position. All that means is that I'm going to turn around 500 degrees and see where I end up. And then standard position is basically like just to the left. I'm always going to face one direction and go to the left. Okay. So what I'm going to do is I'm going to take my x-axis, my y-axis, my coordinate plane. It's called a Cartesian plane, but who cares? So many people care. Please don't hate mail me. I forget that I'm not just talking to you anymore. I'm talking to the whole world. It's weird. It's fine. So what I do is I take my little dude, and he's going to spin around 500 degrees. Let's just start. I know that if I go all the way around, that's 360 degrees. So I know that if I do 500 minus 360, I'll have about 140 degrees left if I do my math right. So then I'm going to go 140 more from going around in a circle. And I know that if this is 90 and this is 180, then it's kind of somewhere in the middle. So more than 90 but less than 180. So there's probably the end of it. And I did that because, once again, 360 plus 140 equals 500. Thank goodness I'm better at mental math than I used to be. So then my angle in standard position would look like this. I moved the whole paper over. Okay? Okay. Let's do... I'm trying to figure out how much space I need. Sorry. Let's just call that good because we're going to do a couple more examples. But actually, I want to do one that's negative because I want to tell you about negative numbers. All positive degrees, I start looking basically to the 0 on x. Or if you think about this as a compass, never eat soggy waffles or whatever, I'm looking at east and going to the north. So I'm going this way and up. If I do negative, let's do an example over here. Let's do negative 400 degrees or something. Because I don't remember what homework I gave you. So, if I do a negative, that just means that I'm going to go, instead of going this way, I'm going to go down. I'm going to go down and around. But it's the same kind of thing. I'm going to go down, around. That's 360. And then I know that I need 400, so I need like 40 more degrees, which would be between 0 and 90. Not exactly halfway. I kind of made it halfway on accident, but it's fine. So that's my angle in standard position. Okay. You can notice that all I'm doing right here is I'm taking a 360 away and just seeing what's left. Same thing here. I just kind of took 360 away from 400 and saw what's left. I didn't need to draw the full circle around because I would just end up back where I started again. So what I could do is just subtract 360, or technically add it to my negative one. So let's talk about this thing called a coterminal angle. So two angles that are coterminal, they end in the same place. Their angle in standard position is the exact same. I lied to you, I'm not done yet. I want to highlight the word angle, and I want to highlight the words coterminal angles in a second when they're dry. So it'll make me sad otherwise. So I want to find an angle. How about this? Let's find two angles coterminal with 740 degrees. Okay. So if I'm thinking about it, 740, I go around the circle, and then I go a little bit more. Maybe a whole other more. Let's figure it out. I don't know. So what I can do is I can take my 740, and I can either add or subtract 360 to find an angle that's coterminal. I kind of want the one that doesn't have any more turning around to do, so I'm going to subtract 360 degrees from that. And naturally, that's where my mental math hurts me. My phone's way over there. Let me get a calculator open. So I'm going to do 740 minus 360, and that's 380. So this angle is what I started with. This is one that's coterminal with it. And then I can take that 380 and I can subtract 360 again. And that I don't need a calculator for, because that's only 20 more. So it'll be 20. So 380 degrees is one possible answer. 20 degrees is another possible answer. If I kept subtracting 30 or adding 30, if I kept subtracting 360 or adding 360, I would find more. But this is only asking me for two. If it asked me for two that was between 0 and 360, I would need the second one. I would need the one that's below 360 but not negative. Okay. Now, here's my favorite part. We are going to talk about this thing called radians. Now, let me see if I can do it right at the right time. I have this thing to show you that BuzzFeed showed on their things that I wish I saw in high school that would help me understand. Okay, so this is a circle with the radius. What they did is they take the radius and they lay it flat against the circle, and that's called 1 radian, because it's a radius worth around the circle. So that's the angle of the radian. So 2, 3 and a little extra gets me all the way around. That's pi, 3.14. So pi radians is half of a circle. And then the full circle would be 2 of those, 2 pi. Next time I'm going to show you how to split up the circle into radians, but today all we're going to do is we're going to translate from degrees to radians just using those two things. So once again, the radius of the circle lay flat against the side, that's called a radian. It's however far I have to go to make 1 radius around the circle. And then it shows us 1, 2, 3, and a little extra makes the full half of a circle. I shouldn't say full half, that sounds weird. So it's 2 of them, 2 pi's, to make the full thing. And that's because it's 2 times pi times r is the circumference. I think that's pretty cool. I think it's pretty rad. Okay. So what we know now is that a radian is a radius of length around the circle. And yes, I did quote a BuzzFeed article in my in my lesson. If you want to doodle something down here about the circle, do it. I don't blame you. Actually, I might put it here once I'm done with my notes. Also, I have no space, so this is what we get. Okay, so here's how we convert. Here's how we convert. We know that half the circle is 180 degrees. Okay, half the circle is 180 degrees. And we know that half the circle is pi radians. Okay, so what we can do is, if we do radians times 180, and we basically just chop off the pi part of the radians, but it's 180 divided by pi. That equals degrees. And if I do degrees times, basically divided by 180, but then add a pi on the end, I get radians. I think that's pretty cool. So if I had 120 degrees, and I wanted to turn that into radians, which we write rad, but we say radians still. That's degrees, so I'm going to take the 120 times pi over 180. So what I do is, in my calculator, which I totally already pulled up and am not going to go to right now. Hopefully you have a yellow calculator, because these are actually easier on those. I didn't want that, I wanted scientific. Okay, cool. Face and internet. Face and internet, there we go. So what I can do is I can do 120 divided by 180. And I really want this to be a fraction, so I do this little circle button over here that says it's 2/3. Okay, so what I have is that I have it's 2/3. So I say that this is 2/3 times pi, or 2 pi over 3. 2 pi over 3. That's a valid radian. I went 2/3 of a pi away, or the way around the circle. Cool. Okay, let's go the other way. What if I had my notes still open? There they are. Let's do negative pi over 12 into degrees. Well, I'm going to take, no more space, negative pi over 12 times 180 over pi. And the cool thing about this is that the pi's actually cancel. So all I'm going to do is, over my calculator, I'm going to do 180, and I'm going to divide that by 12. 15. So this is negative 15, and it's only negative because it had a negative right here. That's negative 15 degrees. It is 1/12 of the pi away around the circle. Okay. This is all you need. So I'm going to go ahead and show you the homework. While I'm doing that, I'm going to highlight a couple things and maybe draw my little circle on here so you can come back. But this is all you need to know, is how to draw any angle in standard form, how to find coterminal angles, and how to convert. And I did one of each of those and then a little matching section on your homework, so should be easy. Now, as usual, you can either do this homework on a piece of paper and upload it to the Google Classroom where it has it as an assignment, or you can do it on bigideasmath.com and make sure you press submit. It's underneath your name, like you click your name and it'll have a drop down that says what it is. So those are your, it's 8 problems, but since 4 of them are matching, I don't feel bad about it. I think you're fine. Okay, I'm gonna highlight and do that. So that was the end. Go do you. If you want to hang out and highlight with me, that's fine too. I want to talk about radians. And I really need to remember this little section right here. So maybe what I'll do is I'll put it in a box. And you know, when I put things in boxes, I don't really want to like really label them in. But there we go. And then over here, I do kind of want to draw my little diagram. I could have put this over here. Next year, I know. Okay. So let me see if I can draw a circle. Oh, nope. Don't judge me. There's an app, or a website that you like draw circles and it judges you for it. This would not be a good one. Okay, so what it showed us was that here's the radius. And then this was a radian. And those were equal lengths. All three of those green lines are equal. And then what it showed us was that this was pi radians, was all the way around. And then this is 2 pi radians, is actually all the way around, because I said all the way when I meant halfway. We do a 180. Okay. I am going to talk about the unit circle next time. We're supposed to leave it out, but I really want you to know it because it'll help you really have a good feeling for what it is. But we'll just fill out a paper so that way you have it. And then this is radians. So now you've remembered degrees, hopefully, from your geometry experience, and now you know what a radian is because that's our Algebra 2 version. Because it turns them into fractions instead of parts of a whole, which is still fractions, but you know. Okay, hey, I really miss you guys. Hopefully you come to office hours if you're stuck, or even if you just want to say hi, I would love that. Even if you feel like I just teach you as a whole class, I really do miss every single one of you. So please come visit me. Email me if you have any questions. Find me if you have any questions. Come to office hours if you want anything. We'll get through this together.